Hi GOH, this is Unit 3, Lesson 9, and today we're going to talk about our last way to prove triangles congruent, and that is hypotenuse leg. Now hypotenuse leg is only for right triangles, all right, because a right triangle, okay, has a hypotenuse. This is my hypotenuse right here. It is the side across from the right angle. And the other two sides are called my legs. So basically I have a right triangle. So I have this angle B and angle E are right angles, and then you have either of the legs, it doesn't matter which one, and I have a hypotenuse. So when two right triangles have congruent hypotenuses and a pair of congruent legs, then the triangles are congruent to each other. The important thing that people forget all the time is in order to use hypotenuse leg, you must first state that the triangles are right triangles. So this is important. This is what people forget. Now, if you forget it, it's not the end of the world, but it's usually a point or two that you would lose. Okay, so hypotenuse leg only applies to right triangles, and you have to first say that they are right triangles. So let's try that out in a proof right here. Given CM is congruent to DM, so I'm going to mark that on my paper. CM is congruent to DM. CA is perpendicular to AM, and DB is perpendicular to BM, and M is the midpoint of AB. So I marked everything that was just in my given right there. Even though I marked it on my diagram, I have to make sure that I am writing each of these steps. So CM is congruent to DM. That's in my given, that's easy. CA is perpendicular to AM, and DB is perpendicular to BM. I got lots of givens here. And M is the midpoint of AB. I'm just going to work in order. I have perpendicular lines. Now hopefully you guys know by this point that perpendicular lines form right angles. So you can see that I put numbers in there. So angle 1 and angle 2 are right angles. The reason, definition, perpendicular lines. Now since they're both right angles, they both equal 90, which means they have to be equal to each other. So angle 1 is congruent to angle 2. Why? Because all right angles are congruent. We've seen this before, and it comes up a lot. So as soon as you have perpendicular lines, the very next step is to tell me which angles are right angles, and then the very next step after that is to say that they are congruent to each other, because all right angles are congruent. Now I also have a midpoint. If M is the midpoint of AB, see how I put a big fat dot on M? It's cutting AB in half. So a midpoint divides a segment into two congruent segments. Tell me which two segments are congruent. The segment on the left, AM, is congruent to the segment on the right, MB. Reason? Definition of midpoint. Now, these triangles are congruent, but it's not angle side side. Remember, angle side side is not a method, but these are right triangles. So therefore, this is the hypotenuse. CM and DM are the hypotenuse, and AM and MB are the legs. Remember what I said though, if you're going to use hypotenuse leg, you have to first say that they are right triangles. So triangle CAM and triangle DBM are right triangles. Don't say they're congruent. You must first say that they're right triangles. Now, why are they right triangles? They have a right angle. They contain a right angle. And since they're right triangles and they have the hypotenuse and the leg congruent, now I can say that they are congruent to each other. So triangle CAM is congruent to triangle DBM, and the reason is hypotenuse leg, and you can just write HL. I do want to point out that technically you do not need this step right here, but we're so used to doing that, I just wrote it anyway out of habit. It's not wrong to put it in, but I'm not using that angle to prove the triangles are congruent, so I don't really need to say those angles are congruent. What I do need to say for sure is that they're right angles, and then because they're right angles, that makes those right triangles. Okay, what rigid motion maps one triangle onto the other triangle? And I would say I did, if you could see, I would have reflected this. Reflection over the perpendicular bisector of AB. Basically, let me get another color out here. If I had the perpendicular bisector, this line right here, I flipped triangle CAM, I reflected it over, and it would land on triangle DBM. Okay, so that is the rigid motion that maps one triangle onto the other. Hypotenuse leg can now be used just as the other four were to prove triangles are congruent and properties come from that congruency, CPCTC. So basically, we're now in the same boat just like we were before of using it, and this is my fifth way to prove triangles are congruent to each other. So in this diagram below, AC intersects DE at B such that AC is perpendicular to DE, and B is the midpoint, there's another key word, of ED, and AD is congruent to CE. All right, explain why B must also be the midpoint of AC. I'm going to write this, you could write an explanation as more of sort of sentences. I just find the proof easier, so I'm just going to do a proof. So AC is perpendicular to DE, B is a midpoint of ED, and AD is congruent to CE. There's a lot of given. All right, so let's mark. AD is congruent to CE. B is the midpoint of ED, so B is the midpoint of ED. It cuts ED in half. And AC is perpendicular to DE, so these two lines are perpendicular, which makes those right angles. So angle 1 and angle 2 are right angles. Why? Because they're perpendicular lines. Now normally I would say that they are congruent to each other, but look the way I marked my diagram. I am not actually using the fact that angle 1 is congruent to angle 2. I have hypotenuse legs, so I don't need to say that. I do need to say though that EB is congruent to DB. Why? Because it was a midpoint. I do need to say that triangle ABD and triangle CBE are right triangles. They're right triangles because they have a right angle. And then I can say that they are congruent to each other. Oops, ABD is congruent to triangle CBE because of hypotenuse leg. I want to prove that B is the midpoint of AC. So basically, I'm trying to prove, let me highlight it, that B is the midpoint of AC. So I have to say that AB is congruent to CB, which once the triangles are congruent, I actually know that AB is congruent to BC by CPCTC. And if AB is congruent to BC, then that means that B is the midpoint of AC. And that's just definition midpoint. So that was fun. Our proofs are getting a little bit longer here. And then we have exercise 3. So PQ is congruent to SR. PQ is congruent to SR. Mark that down. QT is perpendicular to PR, and SV is perpendicular to PR. So that makes these guys right here right angles. I'm going to put a number 1 and a number 2 right in there right now. And also QT is congruent to SV. So QT is right here, is congruent to SV right there. And I'm trying to prove that PV is congruent to RT. PV is, let me just get some different colors here. PV is this whole line right here, and RT, get a different color, RT is this line right here. Now PV PT is part of PV and RV is part of RT. So here's what I need to do, and I don't know if you guys can see this. I'm going to first prove that these triangles are congruent to each other. And I actually have them marked, so they're going to be very easy to prove that they're congruent. I'm going to prove they're congruent by hypotenuse leg. Once they're congruent, then I can say that, I feel like I need another color going on here. Once they're congruent, I can say that, maybe I'll do purple, that this little piece of the triangle is congruent to this little piece of the triangle by CPCTC, and then I'm going to add on that piece in the middle, TV. So that's my plan. Getting the triangles congruent is easy. We've been practicing it for a couple of days so far. This is definitely having you think a little bit more about what I'm trying to do. So I'm just writing down my given right now. SV is perpendicular to PR, and QT is congruent to SV. So you have all the sides, the thing of the angles. Since my lines are perpendicular, angle 1 and angle 2 are right angles. Getting the triangles congruent is going to be nice and short and sweet, quick. Definition: perpendicular lines. This is a hypotenuse leg proof. So remember, I first have to say that triangle PQT and triangle RSV are right angles. They're right angles because the lines were perpendicular, making angle 1 and angle 2 right angles. So they're right triangles because they contain a right angle. And since they're both right triangles, and they have a hypotenuse and a leg, congruent to a hypotenuse and a leg, I can say that they are congruent to each other by hypotenuse leg. Now, once they're congruent, remember all those corresponding parts are congruent. I can't just jump and say that PV is congruent to RT because PV is not a side in the triangle and RT is not a side in the triangle. But I could say PT, which is a side in the triangle, is congruent to VR, which is a side in the triangle. Those are the things I highlighted right here in purple, super dark. Those are congruent by CPCTC. And then, but I want to add on this middle piece because I'm trying to get PV. So I need to add on TV to the left and I need to add on TV to the right. So the thing I'm trying to add on has to be part of my proof. So I'm going to say that TV is congruent to TV by the reflexive property. And then I can say take PT from step 5 and add on TV from step 6. And I can say PV, and I can take VR from step 5 and add on TV from step 6 and say PV is congruent to RT. And that reason is addition. So that was a little bit more interesting, and I think that was our last proof. Yep, and we just have one more lesson tomorrow. So that's it for tonight, and